This video covers section 2.4, part 4, review. This portion deals with simple harmonic motion. Simple harmonic motion is the motion, for example, when you have a spring and you pull the spring out and you let it go. And so it's going to compress and extend, and it's just going to go back and forth between those. And so you can graph the height of the mass on an XY plane, and you'll see that the motion, depending on how you start the motion, is going to look like a sine wave. And the distance from rest to the extended or the compressed is said to be the maximum displacement. We would always call that amplitude in the past. So if you're looking at d equals 20 cosine pi t as the motion, t is in seconds and d is in centimeters, then that means this one's going to start off at its maximum, go through the middle ground, and then to the compression. And so the maximum displacement of this, if it gets up to 20 and down to negative 20, the maximum displacement it's ever going to get is 20. And that's in centimeters. In terms of the frequency and the time required for one cycle, I like to do the time required for one cycle first, because we're good at graphing 20 cosine pi t. We know that the period of this is 2 pi divided by what's in front of the t, which is the pi. We called that omega. And so the period of this is 2, and the t-axis is measured in seconds, so the period of this is 2 seconds. Well, that's the time that it takes to start off at its maximum, go through its minimum, back to its maximum. That is the time required for one cycle. This is 2 seconds. So the time required for one cycle is 2 pi over omega. Now, the frequency is related to the time required for one cycle. The frequency always talks about how many cycles can you get in 1 second. Whereas C is 2 seconds for one cycle. You should see they're just the reciprocal of each other. The time is how many seconds per cycle. B is cycles for 1 second. So you take the reciprocal of this to get the frequency, omega over 2 pi. So we know that if it takes 2 seconds for one cycle, then we're only going to get a half a second. It's only going to take a half a second or a half a cycle in 1 second. You're going to get a half a cycle in 1 second. So omega is pi divided by 2 pi gives us a half. So we say the frequency is a half cycles per second. Usually it's measured in hertz, half a hertz. In the next one, d equals 1/2 sine 4t. This one means that we started it at its average and maybe gave it a little flick, gave it a little velocity to go through and get up to a half, back to 0, down to a half, and back to 0, the maximum displacement being a half of a centimeter. The period of this is 2 pi over 4, or in this case is pi divided by 2, that's the time, pi over 2 seconds per cycle. The time required for one cycle is pi over 2 seconds. Now, if you want, if it makes you feel better, you can estimate that at 1.57 seconds per cycle. The frequency, remember this is 2 pi over omega, and this is omega over 2 pi. It's the reciprocal of the time. It's 2 divided by pi. And this is measured in cycles per second. Which this turns into around 0.637 cycles per second. When you think about what simple harmonic motion is, something that goes back and forth, that's a vibration, or a vibration is an example of simple harmonic motion. Vibrations are things that just go back and forth. Sometimes they drive you crazy, sometimes they're useful. So here we have an object attached to a coiled spring. The object is pulled down in the negative direction from the rest position and then released. In 64, the object is propelled downward from its rest position. Write an equation for the distance of the object from its rest position after t seconds. In 63, we said the object is pulled down. Here's its rest position. We pulled it down and then released it. That means in 63, we pulled it down and then we released it. That's a cosine. Since we pulled it down to its negative direction, it's a negative cosine. And if it's an amplitude of 30, it got down to negative 30 and up to 30. So we're looking at a negative 30 cosine. And if the period is 2 seconds, we know that the period is 2 pi over omega. So to find omega, to put into our distance equation, then we know the period is 2 then omega is pi. And so this equation for the first one is d equals negative 30 cosine pi t. For the second one, the object is propelled downward from its rest position. So you leave this thing at its rest position. And then at time 0, it started at its rest position, but then we propelled it downward. We gave it a little bit of energy to propel it downward so that it starts in its downward cycle and then back through the average, then to max, and then back to average. So this one has to start from the origin, which makes it a sine. But because we propelled it downward, it's a negative, and the amplitude being 1/4 of an inch, Down a quarter, up a quarter. The period of it is 5 seconds. And we know that omega determines the period. We know the period is 2 pi over omega. And if the period is 5 in this case, then we know that 2 pi over omega is 5. So omega is 2 pi over 5. So this equation is negative 1/4 sine of 2 pi over 5 t. This concludes the video for section 2.4 part 4 review.